Coulombs law of electrostatics. It simply states that the force between 2-point charges is directly proportional to the magnitude of the product of the charges, and it is inversely proportional to the square of the distance between them, or to the square of their separation. Let's assume we have 2-point charges. We label them Q1 and Q2. Those are 2-point charges. These 2-point charges are separated between them by a distance. We are going to call the distance of separation R. So according to the law, it says that the force that exists between these 2-point charges, which we shall call force F, is going to be directly proportional to the product of these two charges. It means it's going to be directly proportional to Q1 times Q2, but also it is inversely proportional to the square of their distances apart. So it is directly proportional to the product of the charges and also inversely proportional to the square of the distances apart. So for us to remove this proportionality sign, we are supposed to introduce a constant of proportionality, which we shall call K, and in this case it will become F is going to be equal to K times Q1 Q2 over R squared. From experimental observations, the value of K is equivalent to 9 times 10 to the power 9, which is also equal to 1 over 4 pi epsilon naught. Epsilon naught simply stands for the permittivity of free space, or the permittivity of a vacuum. This is going to be 9 times 10 to the power 9 from experimental observations. And so it means that our formula for the force that exists between 2-point charges is going to be F We have a question here. Find the force between 2-point charges. We have positive 4 microcoulombs and negative 3 microcoulombs, and these 2-point charges are placed 10 meters apart in air. So let's try and draw a sketch of this. We have, let's call this Q1. We have that Q2. It's another point charge. This is negative 3 microcoulombs. Micro means times 10 to the power negative 6. And we have here positive 4 microcoulombs. And these 2-point charges are separated by 10 centimeters. And now we are required to find the force between those two charges. So what is the force due to Q1? We know that our formula from our previous video, our formula F is going to be equal to Q1 Q2 over 4 pi epsilon naught. Epsilon naught is the permittivity of air, but we know that 1 over 4 pi epsilon naught from experimental observations is equivalent to 9 times 10 to the power 9. So it means that our formula there, F, is going to be equal to Q1 Q2 over this is times R squared, right? Times R squared, multiply that by 9 times 10 to the power 9, like that. So this is our formula, the formula we're going to use. So to go back, the force that exists there, our force is going to be Q1. Q1 will be that 3 times 10 to the power negative 6. It's times 10 to the power negative 6 because it is microcoulombs. So it's 3 times 10 to the power negative 6. Multiply that by Q2. Q2 is 4 times 10 to the power negative 6. And multiply that by times 9 times 10 to the power 9. Divide all that by the square of the separation. we are supposed to convert this, supposed to be in meters. So this is 10 centimeters, converting that to meters is 0.1 meters. So divide that by 0.1 squared. And the force we shall get here will be 1.08 times 10 newtons. And this kind of force will be an attractive one. Why? Because according to the law of electrostatics, we said that like charges attract, unlike charges attract, and like charges repel. This is a negative, that's a positive. It means that the force that exists between here is an attractive force of 1.08 times 10 newtons. We are being required to find the resultant on charge B. Now, charge B is in between charge A and charge C. Charge A is -3 microcoulombs and charge C is -7 microcoulombs. Now, let's put this at the back of our minds, the law of electrostatics. It says that unlike charges attract and like charges repel. Now, if we are to find the resultant force on this B, we know that this charge B is experiencing forces due to two charges. It is experiencing a force due to charge A, and it is also experiencing a force due to charge B. Now, if we are to examine the force due to charge A, we know that this is a negatively charged point and this is positively charged. And since these two are charges that are negatively charged, they are of different charges, negative and positive, it means there's going to be a force of attraction in between here. So it means that charge B is going to be attracted towards that side. Likewise, if we look at charge C is negatively charged, B is positively charged. It means that B is also being pulled in the direction towards C because there is a force of attraction in between there. So what does that mean? It means that if this is B, if that is B, it is experiencing a force due to C in that direction, a force of attraction towards C, and it is also experiencing a force of attraction due to charge A. And now our job is to find the resultant due to these two forces. So we shall first find force due to A, get force due to C, and then we find the resultant by subtracting. The greater force is the one that takes the day. So let's find the force due to A, the force of attraction due to A. The force of attraction due to A is going to be equal to, let's begin by, it is going to be QA times QB over 4 pi epsilon naught. But like we said before, 1 over 4 pi epsilon naught is the same as 9 times 10 to the power 9. So it means that this is going to become equal to 9 times 10 to the power 9. Multiply that by QA. What is QA? The charge is going to be 3 times 10 to the power -6. Multiply that by the charge on B, which is 4 times 10 to the power -6. All that divided by r squared. The distance of separation between A and B is 10 centimeters. When we convert that to meters, it's going to become 0.1 squared. And our answer there will be, it is going to be 1.08 times 10 to the power 1 newtons. So now that is the force of attraction due to charge A. So it means that charge A is attracting B by a force of 1.08 times 10 to the power 1 newtons in that direction. So now let's find the force of attraction that is due to C in that direction. So the force due to C, Fc, is going to be equal to QA, that's the charge due to B, QB and QC. So it is QB and QC over 4 pi epsilon naught. So that's going to become 9 times 10 to the power 9. 9 times 10 to the power 9 is the 1 over 4 pi epsilon naught times r squared. 9 times 10 to the power 9, multiply that by QB. B is 4 times 10, it is 4 microcoulombs, so it is 4 times 10 to the power negative 6. Multiply that by QC. QC is 7 microcoulombs, so multiply that by 7 times 10 to the power negative 6. All that is divided by r squared. The distance between B and C is 10 centimeters. Converting this to meters is going to be 0.1 meters, so it will become 0.1 squared. And our answer here for FC is going to become 10.08 times 10 to the power 1 newtons. So we are having our particle now B. Our particle B is experiencing a force in that direction of 10.08 times 10 to the power 1 newtons. That is force due to particle C. And it is also experiencing a force due to particle A, which we already got as 1.08 times 10 to the power 1. So to find the resultant force F is simply going to be the larger force, which is FC, minus the smaller one, which is FA. It is going to be 10.08 times 10 to the power 1 minus 1.08 times 10 to the power 1. Our resultant force will be 9 times 10 to the power 1 newtons, and this is towards charge C. In the figure below, two small equal charges, 2 times 10 to the power negative 8 coulombs, are placed at point A and point B. One of them is positive and the other is negative. AB is 6 centimeters. That is the distance between A and B. Find the force on a charge that is 1.0 times 10 to the power 8 coulombs. On a charge 1.8 times 10 to the power negative 8 coulombs that is placed at P, where P is 4 centimeters from the line AB, along the perpendicular bisector XP. We have a diagram here that tries to summarize this question. It's a bit long. They are talking about two charges that are equal but opposite. These are the ones at A and B. We have positive 2 times 10 to the power negative 8 and negative 2 times 10 to the power negative 8. They are 6 centimeters apart, and we are having a charge P, which is 1.0 times 10 to the power negative 8 coulombs, and it is 4 centimeters from the perpendicular bisector XP. This diagram serves to summarize this whole question. And the question is asking us, they're asking us to find the force that is being imposed on that charge P. Now, if you look at that charge P, the charge P has got two forces that are acting on it. First of all, P is positively charged, but it is experiencing a force due to A, and it is also experiencing a force due to B. Now, what kind of force is being experienced by P due to A? This being positive and this being also a positive charge, it means that there is a repulsive force in between here. So it means that due to A, the force on P will be acting along that direction. It will be repelling it away from here in a straight line. Looking at charge B and P, B is a negative charge, and P is a positive charge. Since these two charges are opposite, it means that there is a force of attraction. So it means that as far as B and P is concerned, the force acting on P will be working in that direction along the straight line towards point P. So if we were to redraw this diagram to show the forces that are acting on P, this is how it would be. It would mean that charge P in that same straight line if you had to consider that straight line and this straight line, it would mean that the force acting on P due to A is repelling that P. It is pushing it away, so it will be acting in that direction. And the force acting on B due to P will be attracting, so it is in that direction. Why is that? Unlike charges attract and like charges repel. And if, according to our question, this B is negative, this is positive. That's why there is an attraction here. This P is coming that way. And between A and P, this is positive. This is also positive, so that there's a force of repulsion. This is being pushed away. So you find that charge P is experiencing two forces. We're having charge, we are having a force due to A, and here we are having a force due to B. So it means overall, if we are to isolate charge P, it comes out like this. There is a force due to A, there is a force due to charge B. This is inclined at an angle to the horizontal. Let's call that angle theta, and let's also call this also theta. So finding the resultant force due to P, it means that you're supposed to resolve the forces due to this point, both horizontally and vertically. We resolve forces due to that point, and after resolving those forces, we're able to find the resultant force that is acting on that point P. If we are to look at this triangle, we could draw a parallel line here going through this point. This line is parallel to this line. So if we are to get this angle theta there, this angle is the same as that angle down here. So these are called Z alternate angles. So if this is an angle theta, that's an angle theta. This here is having 4 centimeters there. We have 3 centimeters this way, 3 centimeters that way. It means for us to find the length of this hypotenuse, it is going to be 4 squared. We use Pythagoras theorem. So it's going to be 4 squared plus 3 squared is going to give us x squared, and this value of x is 5. So this is going to be 5 squared, 5 centimeters. It's the same story in this other triangle. 4 squared plus 3 squared will give us 5 squared, 5 centimeters. So it means that this is 5 centimeters, that's 5 centimeters. That whole thing is, this makes it an isosceles triangle. And if this is the value of theta, one thing about isosceles triangles is that the base angles are the same. So meaning that if this is angle theta, it means that this angle here is also theta. If that angle is also theta, it means that looking at this theta, we say this is theta. This angle is equal to that because these are alternate angles. These are two parallel lines, and that angle is the same as that, according to our angle properties. And then since this line is parallel to this one, this angle is also equal to that angle, because this theta and that is also theta, because they are corresponding angles here and there from our angle properties. So it means that if we are to isolate this charge like we have done here, and this is angle theta, it means that this angle down here is also theta. It simply means that these two angles are the same, no difference. Okay, so now in resolving forces, it means that we are going to resolve this angle, the force FA, along the horizontal and along the vertical, along the x-axis and along the y-axis. We are also going to resolve this force along the x-axis and along the y-axis, and then we shall eventually find the resultant of the two forces. So we begin. When we are to resolve these forces, it would mean that resolving it along the y-axis is going to be FA. We are looking at FA. Resolving it in the y-axis, it would mean it is FA sine theta. then resolving for FA is going to be FA sine theta, then resolving FB along the y-axis is going to be minus FB sine theta, because resolving this along the y-axis we are looking at this. Then resolving the force along the x-axis, the two forces along the x-axis, looking at FA, resolving it along the x-axis is going to be FA, the cosine of that angle, theta, plus FB, resolving it along this is going to be FB cos of theta, giving us R2. So if we get R1 and R2, then we will be able to resolve those two to find the resultant of the force on that particle. But you do not have FA and you don't have FB. So we first find the FAs and FB. Now remember, for us to get FA, it's a repulsive force that is between P and A. For us to get FB, FB is an attractive force between P and B. So we are going to use our formula, the one we used when we are trying to calculate Coulombs Law. When we are trying to illustrate Coulombs Law. And that is that for FA is going to be the charge on A times the charge on B. It's the product of the charges, and divide that by the distance, their mean distance, their separation squared. So QA is going to be 2 times 10 to the power negative 8, which is the charge on A is 2 times 10 to the power negative 8. The charge on P is 1 times 10 to the power negative 8. Multiply that by 9 times 10 to the power 9. This is equivalent to 1 over 4 pi epsilon naught. Divide that by the separation squared. Their separation is 5 centimeters, but it's supposed to be in meters, which is 0.05, and it's supposed to be squared. And that's how we end up with 0.05 squared. And we get our force as 7.2 times 10 to the power negative 4 newtons. So that is 7.2 times 10 to the power negative 4 newtons. So now let's try and find FB. FB, the force that is acting on P due to B, we get this using the same formula. Q, the charge on B times the charge on P. Divide that by 4 pi epsilon naught times R squared. The charge on QB is 2 times 10 to the power negative 8 times the charge on P, which is 1 times 10 to the power negative 8 times this 9 times 10 to the power negative 9, which is equivalent to 1 over 4 pi epsilon naught times the separation. Now the separation between P and B, this is 5 centimeters, like we had earlier found out, and converting that to meters is going to be 0.05, and if we square that, it will be 0.05 squared. Our answer will still be the same as this, 7.2 times 10 to the power negative 4 newtons. So now we are having two forces here. We are having FA acting in that direction, and it is identical to the force FB acting in this direction, acting on that point P. So now we find the resultant of these two forces, the resultant acting on that. So getting our value of R1 means we are going to substitute for the values of FA and FB, which we have gotten. Sine theta, our values of theta here are the same all throughout. So to get theta here, sine theta there is simply opposite, which is 4, over hypotenuse, which is 5. And then our cosine of theta is going to be equal to adjacent, which is 3, over hypotenuse, which is 5, 3 over 5. So we simply come and substitute in here. So resolving along the y-axis is going to be FA times the sine of theta, which is that, minus FB, which we have gotten, times sine theta, which is that, to give us R1. And from our computations, resolving along the y-axis, our value of R1 is 0. When we resolve along the x-axis, our value of R2 is going to be 8.6 times 10 to the power negative 4 newtons. So at the end of the day, we have something like this. We have that our resultant force in the y direction is going to be 0 newtons, and the resultant force in the x direction is 8.6. If this R1 had a value like 5, say, we would go ahead to find the resultant by using the Pythagoras theorem. It would be the square root of the square of that and the square of that combined. But since R1 is 0, it means that the resultant is going to be R2, and it's in the direction of the positive x-axis. So our answer is that the resultant force that is being experienced there is 8.64 times 10 to the power negative 4, and it is happening in the positive x-axis. In this question, we are being asked to find the resultant on force Q3. This is force Q3, and we are being asked to find the resultant on this force, on this charge. Now this charge is experiencing forces due to Q2, due to Q1, and due to Q4. Force Q3 is a positive, charge Q3 is a positive one, charge Q2 is a negative one. Since unlike charges attract, it means that the force of Q3 due to Q2 will be in that direction, because these two are attract. So if this force is to be stationary, this force will be pulled in that direction. The force due to Q2 will be pulling this in this direction. The force due to Q1 will be pulling Q3 away, because this is positive, that is positive, and since like charges repel, it means they will be parting separate ways. So this will be moving in this direction. And then we have charge Q4. Charge Q4 is also positive. Q3 is also positive. It means along this line, the force due to Q4 will be pushing this downwards. And so with that kind of analysis, we'll end up with the forces on Q3 in these kinds of direction like this. We have force due to Q2 in that direction. We have force due to Q4 moving downwards. And then we have this in this direction, force due to Q1. So our task is very simple. We are going to find these forces FQ1, FQ4, and FQ2. After finding those forces using Coulombs law of electrostatics, then we shall find the resultant of these forces, and that will be the resultant force acting on charge Q3. We'll begin finding the force due to Q1. The force acting on Q3 due to Q1, it means we are considering this and that. The charge on Q1 is 2 microcoulombs, the charge on Q3 is 5 microcoulombs. So we begin. FQ1 is going to be equal to Q1 times Q3 divided by 4 pi epsilon naught times r squared. That's going to be, what is Q1? Remember, 1 over 4 pi epsilon naught is 9 times 10 to the power 9. Multiply that by Q1. Q1, if we look here, Q1 is 2 microcoulombs. So it means that our Q1 is 2 microcoulombs. 2 times 10 to the power negative 6. Multiply that by Q3. Our Q3 is 5 microcoulombs. So it is by 5 times 10 to the power negative 6. Divide all this by their separation squared. What is the distance between them? The distance between Q3 and Q1 is 5 centimeters. Converting this to meters is going to be 0.05 meters. So this squared, this is going to give us 0.05 squared. And our force FQ1 is going to become 36 newtons. So we find force acting on Q3 due to Q4. So FQ4 is simply going to be equal to Q3 Q4 over 4 pi epsilon naught r squared. R is the distance between the two charges. That is simply going to become 9 times 10 to the power 9. We said 9 times 10 to the power 9, according to experimental observations, is what is equivalent to 1 over 4 pi epsilon naught. Multiply that by Q3. We know that Q3 is 5 microcoulombs and Q4 1 microcoulomb. So continue with our calculation. It's going to be times Q3, which is 5 times 10 to the power negative 6, times Q4, which is 1 microcoulomb, so it's 1 times 10 to the power negative 6. Divide all that by the distance between them. If you look at our diagram, the distance between Q3 and Q1 is 3 centimeters. Converting this to meters is going to be 0.03 meters, and it means that this is divided by 0.03 squared. 0.03 is our value of R. So our answer here will be 50 newtons. So we find the final force that is acting on Q3 due to Q2. That's going to be Q3. Q2, divide that by 4 pi epsilon naught R. That's going to still be 9 times 10 to the power 9 times 5 times 10 times Q3, which is 5 times 10 to the power negative 6. Multiply that by Q2. Now Q2 is 3 microcoulombs, so it's going to be 3 times 10 to the power negative 6. Divide all that by their separation. The distance between Q3 and Q2, the distance is 4 centimeters. Converting that to meters is going to give you 0.04 meters, and so it means that this is going to be equal, divide that by 0.04, and this is squared. So our answer here will be 84.4 newtons. That is our force, the force acting on Q3 due to Q2. So now at the end of the day, this is what we have. We are having a charge, a point charge, but that we are calling Q3, and it is having 3 forces acting on it in this kind of manner. It is having a force acting that way, FQ2, which we have found to be 36 newtons. So from this we are going to now resolve these forces along the x-axis and along the y-axis, and then we will be able to get the resultant of the forces. So after the analysis, this is what we have. This is our point charge, Q3. It's here. And it is subject to the forces Q2, which is 84.4 newtons in that direction, Q4 50 newtons pulling it in this direction, and 36 newtons pulling it in that direction. And our task here is to find the resultant force acting on that point. Finding the resultant force acting on that point means that we are going to resolve each of these forces both in the x and in the y. So we shall get the total resolution of forces in the x direction, we get the total resolution of forces in the y direction, and we get the resultant using this formula. So we begin getting the resolution of forces. So we first have to get the resultant force in the x direction, resultant force in the y direction for each force. So we shall get the resultant force for FQ1 plus the resultant force both in x and y direction for FQ2, which is that. Then the resultant in that direction also, FQ4. So we go ahead and say for FQ1, which is this force, resolving it in the x direction, it is FQ1, this force, cosine of theta. How does that come about? If you look at our diagram, we'll try to complete it like this. You find that it's inclined at an angle theta. And this point Q, remember, is at a certain point in our square, as per our question. According to our question, this is 4 centimeters, this is 5 centimeters, this is 3, that is 3 centimeters. So let's transfer this information down here. Here is 4 centimeters, right here is 3 centimeters, so meaning this is 5 centimeters. According to Pythagoras theorem, this is 5 centimeters, the diagonal. Now this is our angle of inclination, theta, and if you look at this theta, this angle is equivalent to that angle. Those are vertically opposite angles, so this angle is also the same as that. This theta is the same as that. So as we are resolving this FQ in the x direction, so it is FQ1, the cosine of theta, because we are resolving along that. And it is negative because it's on the negative side, so it's negative that. Resolving it in the y direction, we are resolving it along this direction. It is negative, and so it's going to be FQ, that is 36, times the sine of this angle to get the component in the y direction, which is that. Then we go ahead, this is going to be plus FQ2. FQ2 has only the component in the x direction, in the positive x direction, so it is positive 84.4. And in the y direction, this post does not have any component, so that is 0. Plus FQ4. FQ4 has got no component in the x direction, so that's how we have a 0. And then in the y direction, it is negative 50 newtons. So we do the arithmetic, we substitute for those cases here. How do we get cosine of theta? Remember we said that this theta is the same as that theta, so to getting this cosine of this theta, cosine of theta is going to be equal to opposite over hypotenuse. Opposite of this theta is 3 over hypotenuse, which is 5, so it is going to be 3 over 5. And then the sine of that, the sine of theta is simply going to be adjacent, which is 4 over hypotenuse, which is 5. 4 over 5. And that's how we get the figures for which we substitute for this cos and this sine. So it becomes FQ1 is 36. So it's 36 times that, plus that and this. So we'll end up with the total resolution of forces in the x direction is 55.6 newtons, and the total in the y direction is 71.6 newtons. So to find the resultant is to simply find, we substitute in the x bar squared plus the y bar squared. Our resultant force is 90.65 newtons. So if our resultant force is 90.65 newtons, it means that our point charge Q3 is like this. This is our point charge Q3. It is in the x direction, it is positive 55.6, so it is acting in that direction. 55.6 newtons. And in the y direction, it is acting in the direction, it is negative 71.6, so that's why it's pointing downwards as 71.6 newtons, because it is negative. So finding the resultant of this, the resultant lies along there. The resultant force, let's call the resultant force R. And it is inclined to the horizontal at a certain angle we shall call alpha. So getting this resultant is what we are using. We used Pythagoras theorem to get the resultant. 55.6 squared plus 71.6 squared. Because at the end of the day, this is 71.6, the same as this. 71.6. So this squared plus that squared should give us that resultant squared. And that's how we get 90.65 newtons. So after getting the 90.65 newtons, now we seek to find the direction of the resultant force. The resultant force is inclined to the horizontal at a certain angle we have called alpha. So to get that angle alpha, we shall use trigonometry. Tan of alpha, which is that, is going to be equal to opposite. The opposite of this angle is 71.6, which is that. Divide that by adjacent. The adjacent is 55.6, which is that, 55.6. So we shall end up with our alpha as 55.2 degrees. So we shall conclude by saying that the resultant is 90.65 newtons at 55.2 degrees to the horizontal. That brings us to the end of this video. Thank you for tuning in. Please don't forget to comment below and hit that like button. Someone out there may like to watch this tutorial. Don't forget to share. Otherwise, for more videos, simply subscribe to this channel. For Kisembo Academy, this is Arnold Coulomb.